Picking up where we left off, we have 2 minus 12, which is negative 10, and that equals to 3 times negative 1, which is negative 3. Now we know negative 10 and negative 3 does not equal each other, so we draw a line through the equal sign, and our answer here would be no, because the question asks, is 3 a solution to the equation 2 minus 4x equals 3 times the parenthesis x minus 4. And we know since our equation is not equal after substituting in 3, then the answer is no. That is not a solution. Now we go to objective 4. It says translate English sentences into algebraic equations. Now we have equality. The English definitions of equality is equal, yields, is, and gives. These are words that represent the word equality. And the symbol is the equal sign. Now we scroll down here to some examples. We have example 5. It says write each sentence as an equation. Let x represents the unknown number. It says the quotient of a number in 6 is 5. Now when we deal with quotient in Math 31 and higher, what we would do is write this quotient as a fraction. So a number is x divided by 6. Is means equal, and 5. So this is the quotient of a number in 6 is 5. So it's x over 6 equals 5. Now we come to b. 7 decreased by twice a number yields 1. So it's 7 decreased by twice a number, which is 2x, yields means equal 1. So it's 7 minus 2x equals 1. Now we scroll down here. Now the tip about the commas, you can read that at your leisure. But what we're going to do, we're going to scroll down here and do example 5. It says the product of a number in 13, comma, added to 3 times the number, comma, gives 4. Now we know that all of these are linked together. But if you notice here, it says added to. Now you notice there is a shift when I write in these boxes here. So I'm going to go down here and do C and then D. So here it says the product of a number in 13, comma, added to 3 times the number. So we'll do 3 times the number, which is 3x, and then the product of a number in 13. That would be added. So it'd be 3x plus 13x, and it gives us 4, which means equals 4. And that is it, because they just wanted us to write the sentence. Now, sometimes, depending on the program you're using, especially with us using MyMathLab, you may have to combine a like term. So just in case you do, we know 3x plus 13x is 16x, and that equals 4. Now, if you're doing MyMathLab, I would suggest you try this first. And then if that doesn't work, then combine the like terms. Okay, now we go to D. Now it says the product of a number and 13 added to 3 times the number. So what we would have to do is, it says the product of a number we know is x, and 13 added to 3 times the number, we have to put a parenthesis, and then we will have 3x plus 13. Now this is the product, which is x times the 13 added to 3 times the number, which is here, and it gives us 4. The commas do make a significant difference. Now we scroll down here. Now we come to another situation where we have a definition. It says a formula is, it's an equation, it's an equation that expresses a relationship between 2 or more variables. Okay, now we want to give a couple examples. Now we could use the Pythagorean theorem, which is a squared plus b squared equals c squared. Or we could use the perimeter formula. The perimeter of a rectangle is 2 lengths plus 2 widths. We could use circumference, which is 2 pi r. Now, if you notice here, we have at least 2 variables that we're comparing. Okay, these are just a couple formulas. You know plenty more, like you could do a formula for Celsius. You could do, let me just add this in here, area. Area of a rectangle is length times width. Okay, now let's look here at example 6. It says here, a variety of cricket chirps faster as the temperature rises. You can approximate the temperature by counting the number of chirps per minute and using the formula T equals 0.3 N plus 40, where T is the temperature in degrees Fahrenheit and N is the number of cricket chirps per minute. Okay, now we come to A. It says, what is a reasonable estimate for the temperature if you count 95 chirps per minute? Now again, N represents the amount of chirps. So we have T is equal to 0.3. Now N is 95 plus 40. Now we're going to multiply this. 0.3 times 95 will give us 28.5. If I could get this to loop here. So it'd be 28.5 plus 40. So 28.5 plus 40 will give us 68.5. Now it says, what is a reasonable estimate for the temperature if you count 95 chirps per minute? So it'd be approximately, we could round to the nearest degree, it'd be approximately 69 degrees Fahrenheit. It says B, what would you conclude if you counted 1,000 chirps per minute? So what we would do is we would substitute. We have T is equal to 0.3, substitute in 1,000 for N, plus 40. So we have T is equal to 0.3 times 1,000 is actually 300 plus 40. So T is equal to 340 degrees Fahrenheit. So what we can conclude is this here. For 1,000 chirps, it takes, the temperature will be 300 degrees Fahrenheit. But there's another thing we can conclude. We know a cricket cannot survive at 340 degrees Fahrenheit. So we could also conclude that it will be impossible for it to get up to 1,000 chirps as well. And that is it.